So kia ora koutou katoa, ko Sheila Matthews tōku ingoa. I'm manager of the Future Security and Resilience FSR team here at the Electricity Authority. And with me today to present this webinar, I have Nasser Faruqi and Elset Grant-Feige from the FSR team. Next slide, please. Yeah, thank you. So what we wanted to cover today was the context for and the purpose of this webinar. We also, it'll be an opportunity for you to ask questions. We ask that you pop the questions into the Q&A function on your screens. We're going to give you an overview of the paper and also talk about the next steps. Questions at the end of the presentation, and if we don't get through all the questions, we will get back to you with responses after the webinar. Slide, please. So what do we know about the power system? We know that it is changing. It is changing with all the new technologies coming on and with renewable energy, which is mostly coming in the form of distributed energy resources. We are monitoring the changes. We've published a series of indicators, which is available on the website, and we're monitoring things such as system inertia, the increase in distributed generation, and so on. We also know that there will be an increase in the demand for electricity with the electrification of sectors such as the transport sector and heat processes. So with all these changes, operating the power system is going to have to evolve to stay fit for purpose. One thing, though, that's not very clear at this stage is how much the operation of the power system is going to need to evolve to ensure that it's fit for purpose. So what are the changes already happening? We see an increase in the DER connecting to the system. And while some of the generation coming on is geothermal, our conventional synchronous generation, most of it is inverter-based wind and solar PV generation. So this renewable energy is connecting not just directly to the transmission grid, we're also seeing it connecting all of the system in the distribution networks and also at the very end, at the consumer end of the system. So with the larger portion of new generation being weather dependent, it's also going to lead to an increased reliance on these weather sensitive sources of generation. Again, all this is going to have an impact on the security of the power system. Our traditional assumptions are going to change and not going to hold effect. We know we had a largely centralized power system comprised of synchronous generation. We have unidirectional power flows, but with the transition to mostly inverter-based generation, it's changing the behavior of the system as we know it. DR connecting at different parts of the system, we have increased levels of bidirectional power flows, and we also know that inverter-based generation behaves differently to our traditional synchronous generation. It has an effect on things like system inertia. And so again, the power system operating model in its current form is going to need to evolve to accommodate these changes. I did mention earlier how one of the changes is that consumers are also getting to be part of the power system. They are connecting solar PV onto their roofs, they've got batteries, so they are becoming prosumers. They can now use power from the grid, but they also have the capability of exporting power back into the grid. So the role of consumers is going to change as a result of this capability. We need to ensure that the system operates in a way that benefits the consumers in the long term. This is going to give consumers the ability to be resilient in times of disruptions to the power system when they get disconnected from the grid. And what we know is that visibility of information and coordination are going to be key to ensuring the system security and reliability for these consumers and for everyone. So how are we preparing for these changes? So the authority has got a number of key projects underway, such as updating distribution of regulatory settings. We published a paper last year, Consultation Paper. There's the potential solutions for peak electricity capacity issues. This is a paper recently published that looks more at the short to medium term initiatives that we are looking into for security of supply. We also have a piece of work looking at the improving the accuracy of intermittent generation, and that's going to become more and more important with weather-dependent sources of generation. However, today's focus is on the future system operation consultation paper. This forms part of the wider FSR work program. Now, the FSR work program, to give you a bit of context, it began in 2021, and it was in response to one of the recommendations from the government's 2019 electricity price review. So the purpose of the FSR program is to ensure that the system stays secure and resilient as it transitions. And the focus is more medium to long term operation of the power system. So how did the FSR work come about? Just over a year ago, we discussed our FSR roadmap. We've got a roadmap which identifies potential challenges and opportunities as the system transitions. We took that to stakeholders, and we just wanted to ensure we had captured all the challenges expected over the coming years. The FSR Workstream, or the Future System Operations Workstream, was initiated as a result of feedback from those sessions, where stakeholders indicated that we needed a coordinated approach for the operation of the power system as it evolves. As the power system, we know it goes across generation, transmission, and distribution. Given the authority's independence and pan-industry view, we are well placed to facilitate this review, working closely, of course, with the industry stakeholders. And so the first step for this work stream was the consultation paper that's just been published. I'll go through the structure of the paper now. It's the main body or the main content is in sections 3, 4, and 5, and that's what my presenters and I will take you through. Section 3 covers the current system operation. 4 covers the key drivers of change that we believe are going to have an effect on the power system operation. And section 5 is going to talk about the various roles and system operator obligations. We'll also talk about whether there's any significant conflicts of interest, perceived or otherwise, associated with roles such as network ownership, operation, and planning. So as I said, the section 3 talks about the current arrangements for system operation in New Zealand. Appendix A is tied in with section 3, and it summarizes some of the key regulatory obligations that are related to power system operation. It's quite a long section, Appendix A, and what it does indicate to us is that it's the extensive number of regulatory obligations that will need to be considered if changes are required in future to get the operation fit for purpose. So section 3 is tied in with Appendix A. It also looks at the roles and responsibilities of the various parties involved in the power system operation, including regulatory requirements. We talk about Transpower as a system operator, as the grid owner, the role and responsibility of distributors, and the ancillary service providers who play a key role in the operation of the power system. We then also talk about the role and responsibilities of the various regulatory bodies, the Electricity Authority, the Comms Commission, and WorkSafe New Zealand. So in this section, we are looking for feedback on whether you agree with what we say to ensure that gaps, if any, are identified. And this is going to be important in establishing a common understanding of the current arrangements. That feedback will help build our understanding for the future and for the next steps in this work stream. To take you through the next section, section 4, I'll hand over to Nasa.
Thank you, Sheila. So if we take this section looks at the key drivers of changes. So if we take a step back and see how the system operation is changing, is that we identified certain factors that can be classified and put into the 6 different baskets, where we look at generation, consumer, operation, information, climate change, and electrification. So earlier, the transmission and the generation part of it was all based on the physics of electrodynamics of rotating machines, which were hydropower plants, nuclear power plants, coal-based power plants. And at the distribution level, we have our consumer electronics and electrical apparatuses and industries. Next slide, please. So the key change and the key driver change now is in the generation technology, and that comes in the form of inverter-based technology. This inverter-based technology can be wind power, it can be solar, and it can be battery energy systems. And these are power electronic based devices that are integrated into power system, and that creates a problem because they work on algorithms, and the algorithms, it's not mature enough technology to understand the power system dynamics. And as you see on the screen, we do have issues of stability, protection, control system issues, and also for the grid forming or black start, other oscillation issues are identified with this type of generation technology. Next slide, please. And the second key driver is the consumer technology. The consumer load is no more the washing machines and the televisions. So we do have now prosumers where we can generate electricity through solar rooftop PV. We can arbitrate the value and the time of the energy use by using battery energy storage. We do have bidirectional electric vehicle chargers. The prosumers can also participate in the demand response. So the consumer technology is changing, which will have an impact on the distribution network. And instead of trickle down, it will be trickle up to the transmission network operator. Next slide, please. The other key driver, the third key driver is the operational technology. Now, with the change in the generation and the consumer, the way the business models are operating is very different from what has been happening for the last 100 years. So in the regulatory settings, we do have terminologies like EDBs, electric distribution boards, or distributors. But nowadays, some of the distributors are identifying themselves as DSO, distribution system operators. And the reason is that because the energy management is not over an hourly basis, but it is happening on a minute-by-minute basis because of the variability and intermittency of renewable energy systems. We do also have technologies like peer-to-peer, where we can have blockchain technologies and have smart contracts, and we can have different users exchanging energy between themselves. So this type of operational technology needs to be addressed in the future. Next slide, please. For the fourth important driver is the information technology, which is the digitization and digitalization. Back in early days, we used to have the system operator using the telephone to make a call to open and close the circuit breakers. But that was the state of the art back then. But now over every second, we do have a lot of gigabytes of data being generated. And the issue is that these electromechanical devices needs to be optimized to use this particular technology. Otherwise, it's going to have an impact. We do have smart data coming from the residential area. We have smart data coming from the industries, from the generation side. So this information sharing and coordination is very important for the transmission system operator, the distribution system operator, the aggregators, as well as consumers. Next slide, please. And the fifth key driver is the climate change. The cyclone Gabriel was a wake-up call for New Zealand, but we have been lucky enough. The other countries have been having these kind of issues for a long time now. The US, UK, and the other places, they have winter storms. They have cyclones that are affecting the infrastructure, the electricity, that has cascading effects on the other infrastructures such as communications and finance. But what we understand from different climate science agencies is that the frequency and the intensity of the climate change is going to increase. We're going to see more of this kind of climate weather events that's going to happen. And we need a better type of cooperation between the transmission system operator, the distribution system operator, again, the consumers, to tackle these weather events. And the sixth driver is the electrification of energy system, starting basically with the transportation. There's a lot of changes happening in the transportation sector. We are having electric vehicles. We are going for the electric aeroplanes, and then we are also looking at mass scale electrification of transportation systems, which is going to increase the electrical demand in the future. At the same time, the industrial processes are also going to get electrified because of this huge demand. And also we see the data centers coming up in the cities. So we have Microsoft and Amazon being set up in New Zealand. So with these changes in the demand, we need to look at the issues that might arise in the future. So to look at the challenges and also to look at some of the possible solutions, I now hand over to Elzeth, who will be talking about this in the next section.
Thank you, Nasser. I'll now take you through section 5, which builds on what was just covered in section 4. This section explores 4 broad questions about the possible challenges and opportunities for the power system as a result of the drivers of change that we've just discussed. I would like to point out that the authority has not yet formed a view on any of these questions at this stage, and we're looking for feedback and views that will determine what our next steps are. Sorry. So the first question explores whether the system operation is sufficiently coordinated given the changes we expect in the future. In the future, we will see a number of changes in the power system. It'll become a lot more complex, both in real time and over longer periods of time. There'll also be a lot more participants in the power system, mainly consumers and aggregators through the use of DER, as Nasser has already touched on. We also expect there to be more DER connected to the power system as improvements in technology drives down the price of DER. The management of day-to-day power system operations is also likely to become increasingly automated. So this includes the control of frequency, voltage, and network loading. These changes will mean that we are likely to need much greater communication, especially between the system operator, distributors, and parties operating on the networks. In addition to the broader question about sufficient coordination, we're also interested to hear from new players in the markets for flexibility and ancillary services about barriers they may face to participate more in these markets. We're also interested in developments overseas that is useful and relevant for New Zealand. So if you're aware of anything, we are interested to know through your submission. The second question focuses on whether DER is compatible with existing system operation requirements. We have already discussed that we expect to see much greater use of DER and IBRs in the future. And this will create a lot of challenges for the power system. A key issue is the lack of visibility and control of DER. This impacts power system operation at both the distribution and transmission levels and require coordination to use the network most efficiently. We want to make sure there is consistency between the electricity market settings and the technical requirements of power system operation. It is also important that consumers have solutions that enables choice, affordability, and reliability of security supply. A whole of power system approach is likely to be needed to the planning and operation to unlock the full potential of consumer-side technology development. And Sheila has already touched on this in her slides earlier. The authority is already addressing some technical concerns through our review of Part 8 of the Code, which deals with common quality. However, we do realise that other parts of the Code may also need to be changed in the future. In addition to the broad question, we're also interested in your views on the authority's role in relation to future system operation. Is our role to facilitate change primarily through code amendments or through other measures or policies or both? Next, we turn to whether there will be sufficient coordination of network planning. It is expected that there will be significant transmission and distribution network investment needed over the coming decades to support a transition to net zero emissions. Having the most efficient level of network investment can have significant benefits to consumers by making sure that line charges are no higher than they need to be. Sufficiently coordinated network planning includes vertically, so between transmission and distribution levels, as well as horizontally across regions and distribution networks. Coordination also includes whether network planning is being sufficiently informed by wider energy planning activities across sectors that are relevant. These include gas, heat, hydrogen, and transport. Having a more coordinated approach to network planning would require distributors and transport, as the grid owner and as the system operator, to share information more in depth and also more regularly. Several overseas jurisdictions have introduced changes already to help ensure optimal levels of coordination. And the consultation document provides some examples of those, particularly Ireland, Australia, and the UK. And lastly, the authority is interested in understanding whether conflicts of interest may exist in respect of power system operation, electricity network ownership, and electricity network planning during the transition to net zero emissions? Or are these conflicts likely to emerge? Conflicts of interest can happen when there are parties with more than one role in the power system. This could apply to transpower and distributors, as they each perform various roles across the power system. And these conflicts can be potential or perceived. Next slide, please. The conflicts of interest happen when there is a misalignment of incentives between different roles of network ownership, operation, and planning, and where these roles are all performed by the same or related entities. It can also happen when there is some bias towards known solutions to increase the size of the network rather than relying on unproven non-network solutions. Having conflicts of interest could lead to suboptimal outcomes, which means we are not investing in the most efficient network solutions. However, we already have some safeguards in place to prevent some conflicts occurring, and these are mostly under the Code and the Commerce Act, but there is a list of examples also set out in the discussion document. The paper also provides examples of other countries that have made changes to ensure that there are no conflicts of interest in their power system. One of the most recent examples is the UK, who established an energy future system operator. While this is a very interesting example, we realise that New Zealand is quite unique and we do not have the same industry structure or ownership as the UK. So to recap, New Zealand is in a very unique position as we already have a significant level of renewable electricity generation. However, moving to a fully renewable power system still presents us with challenges and opportunities. It is very important that we work collaboratively to achieve the best outcomes for New Zealand and consumers. We encourage you to provide feedback on this consultation paper. So how do you do that? Section 1 sets out all the details about how to make a submission, and in particularly Appendix B of the consultation provides the format for submissions. It would be great if you can have submissions to us by 5 p.m. on Thursday, 11th of April. And if you have any queries or would like to meet with us individually, you can reach us at the email address that's on the screen, and it's also in the consultation paper.
Thank you for your time and thank you for joining us today.